All right. In this video, we're going to take another look at another one of these trig problems where we need to actually think about two different right triangles in order to solve the problem. This is one where I want you to think about how you would tackle this problem. So as you look at this problem, think about how maybe the triangle that we're looking at first glance is not a right triangle, but find some right triangles in the diagram, figure out what you can solve about them, and then see how that information can help you solve the problem that they're actually asking you about in this problem. Let's take a look at what we've got here. So as modeled below, the movie is projected onto a large outdoor screen. So the bottom of the 60-foot tall screen is 12 feet off the ground. So over here in the diagram, here's the screen up here, and then there's some space between the bottom of the screen and the ground. The projector sits on the ground at a horizontal distance of 75 feet from the screen. And they're asking you to determine and state to the nearest tenth of a degree the measure of theta, the projection angle. So they want you to measure this angle right here. So as I say, pause the video, see if you can come up with some right triangles in this diagram, and see how much trig you can do to help you take this apart and identify the side of at least some angles around here, and see if that narrows you in on finding the angle that they're actually talking about. So the first problem here is finding any right angle at all so that we've got some right triangles. Where is there a right angle in this diagram? Well, there's a right triangle right there. So based on this, I can see two right triangles. And I'm going to make sketches of them. Once again, I'm going back to those key ideas that we started with at the beginning of this module. So I've got two right triangles that look like this. So mark this in your worksheet. And now if you haven't gotten this far in the problem before, I want you to see which numbers you can put into these two triangles based on the numbers that are in this diagram over here, and see if that can help you solve the problem that they're asking. Well, the base of these two triangles is equal to 75, so that part is pretty easy. This short triangle has a height of 12. And what's the height of the tall triangle? The tall triangle with this right angle has a height of 12 plus 60. The top of the screen is 60 plus 12, which is 72 feet above the ground. All right, and in both of these cases, what angle do you think we should solve for that can help us answer this question? Well, here we're talking about this angle over here on this part of the diagram. So in this case, let's call this theta prime, and I'll call this theta double prime. All right, so now that I've got right triangles filled out, let's put this problem off to the side. And now these are two problems that we've been solving over the course of this module. So pause the video and calculate these angles for me. These are just the same processes. Go back and look at the worksheets that we've done on previous days in order to figure out the steps for calculating an angle when we know two sides of a right triangle. So here's the angle I'm interested in. So this is not the adjacent leg, this is the opposite leg, and this is the adjacent leg. And the same thing is happening in this triangle here. So when we're talking about SOHCAHTOA, both of these triangles are talking about opposites and adjacent. So which trig function do we use? Opposite and adjacent goes with tangent. So the tangent of theta prime is equal to opposite over adjacent, 72 over 75. In this one, tangent of theta double prime is equal to, once again, opposite over adjacent, 12 over 75. Let's grab our scientific calculator and calculate the angles that form these right triangle ratios. So 72 divided by 75, and the inverse tangent of that, we're supposed to be measuring the angle to the nearest tenth of a degree. So let's measure these to the nearest tenth of a degree. So that's 43.8 degrees. We're rounding down. And for this triangle here, we've got 12 divided by 75. And I want the inverse tangent of that. And so theta here, theta double prime, is equal to 9.1 degrees. All right, so these are very interesting facts. Let's put these facts back into this diagram and see if we can use it to answer the question that they're asking. Well, what does theta prime look like? What angle is that in this diagram? Well, that's the one that goes from the line of sight to the top of the projection screen to the ground. So this whole angle right here, I'm going to write 43.8 here, 43.8 degrees. And how about theta double prime, 9.1 degrees? What angle in this figure has a measure of 9.1 degrees? Well, this is the 12 and 75. So this is this small triangle down here. So this is saying that this angle right there is 9.1 degrees. So did those facts help me answer the question that they're asking here? Yeah, it does, because this angle that they're looking for here is the difference between these two angles. This is the part of the entire angle that's not taken up by this bottom part. So theta is just equal to theta prime minus theta double prime. And so one of them was 43.8 degrees. The other was 9.1 degrees. And subtracting that, we get that the projection angle is equal to 34.7 degrees. All right, so that was a problem that involved us finding some right angles so that we can set up trig equations, and then using that, we were able to find two angles that were related to the angle they actually asked us to find. So this is a little bit of a trickier problem. You need to set up the right triangles and see how information in those two right triangles can help you to solve the question that they're asking you about. So I've got 3 problems for you to do that are associated with this type of problem. These are trickier problems. What I want to see is I want to see you trying your best on these. If you can make it through them, that is fantastic. If you can only go through a few steps in this, I want you to go a few steps through it. What I don't want to see is a blank sheet of paper because you didn't even get started. All right, problems only get solved when you start to attack them. And when you start to attack them, you might find that you get further than you had thought that you might have. So give it your best shot and show me what you've got.